All right, guys, for this video lesson, we're going to talk about symmetry, which is even and odd functions. We've graphed a lot of basic shapes so far, but we haven't talked about if some of the graphs have any symmetry. All right, and even when we graph later, we're going to graph rational functions. What's going to help us out is we can look at a function and tell if it's even or odd, which will also tell if it's symmetric to certain parts of the coordinate plane. So what you can take down right now is what we have in this chart. Hopefully you've seen this before. So if I have a function or an equation that's even, you're going to see the graph is going to be symmetric to the y-axis. And we've seen this happen with some of the basic shapes. We'll graph it and we'll see that it's symmetric to the y-axis. So what that means is if you fold the graph over the y-axis, the parts of the graphs lie on top of each other. Now, what does that mean algebraically? This kind of is, I guess you would say, like a more um, mathy way of stating it, which I don't really like. But basically, what this means, if a function is even, if you put in a number for x and then also an opposite number for x, you're going to get the same thing. So that's why we say the function of negative x equals the function of x. Here's a way that I think is a little bit more concrete. If you graph an even function, then xy and negative xy are going to lie on that graph. Put lie on the graph. All right. And I'm going to go down and I'm going to show you a first example. Well, why is it called even a lot? If you look at the first example, the x squared, okay, if I just kind of focus on this. Well, I know this is a parabola and it's symmetric to the y-axis, right? It has an even exponent. Here's what I mean by that xy and negative xy lies on the graph. A good test is, if I just put 1 and negative 1 in, I'm going to get the same y value, right? 1 squared is 1. But if I put negative 1 squared, that also gives me 1. And it works for every number and its opposite for x. Right? If I put in 2, 2 squared is 4. If I put in its opposite, negative 2, you still get 4. So this kind of proves that it's an even function. All right. And then when you look at the graph, you see it's symmetric to this y-axis. So this is an even function. Okay. Now if I go up, oops, if I go up and I look what's in the blue here, the odd functions, I always think of the O's. An odd function is going to be symmetric to the origin. And then what happens for this, if you plug in a number for x and its opposite, the y values are going to be opposites. So it's another O. So I think of the O's for odd, symmetric to the origin, begins with an O, and you get opposites. So what this means, I think this is the easier way of explaining it algebraically. If we make an XY chart, XY and negative X, negative Y lie on the graph. So you can see how the opposites lie on this graph. All right. Well, if I go to number 2, this is an example of an odd function. Right. I have x cubed. It's raised to an odd power. And if I graphed it, right, this is the S curve. And you can see you can kind of twist it around the origin and they would lie on top of each other. But to do it algebraically, I'm going to do the test to plug in 1 and negative 1 in. And when you plug in 1 cubed, you get 1. But now when you plug in negative 1 and you raise it to an odd power, it's going to give you the opposite. So this is the difference here. This gives me negative 1. I could keep going, right? 2 cubed is 8. If I plug in its opposite, negative 2, negative 2 cubed, since it's raised to an odd power, is going to give me a negative. So right, when I see that these are opposites, right, that begins with the O, then we say that this is an odd function. All right, and this is really going to help us graph um, rational functions, which is the next set of functions that we're going to graph. Now I'm going to take a look at the next 4, and what I'm really going to do, I'm not going to graph because it's going to take a while to graph. I'm just going to use this test right here. And it's real simple. You can just plug in 1 and negative 1, 2 and negative 2. Before I even go on, I will say, if you get an XY chart and you don't get like let's say I plug in 1 and -1 and I get 2 and I get 3, then we would say this is neither. I know it's kind of weird, dealing with numbers is either even or odd, but for functions, if you get the y values here to be the same, it's even. If you get these y values to be the opposite, they're odd. And if it's not that, the same or opposites, then we say neither. All right. So if I were to do um, 3, now 3, you might be thinking, oh, this is going to be odd. I get it. It's just an odd exponent, but it's not going to work out that way. And you'll see the -1 is kind of what messes it up. So if I just did this, right, quick check, I want to plug in 1 and -1. So if I did 1 cubed minus 1, well, that would just give me 1 minus 1. That would give me 0. If I plug in -1 cubed, well, -1 cubed is -1, but then -1 minus 1 is -2. Here's an example. The 0 and the -2, it's not the same. They're not the opposite. This is neither. And if you looked at it graphically, well, that x cubed minus 1, you would just bring it down 1 unit. It would look like this. Just shifting it down 1 unit, it's no longer symmetric to the origin. Okay, let's move over to 4, and I'm just going to do this. This is the quickest, easiest way, right? It would take me a while to graph this. So let's just use this quick check of using the XY chart. All right, let's plug in 1 and -1. Let's see here. If we get 1 to the 4th minus 1 squared, well, that's just going to give me 1 minus 1, and then plus 1 just gives me 1. And then -1 to the 4th minus -1 squared, you can see it's going to give us the same thing. Right? This is still going to be 1 minus 1 plus 1, which is 1. Since these are the same, this is an even function. All right. And if you're still not sure, plug in 2 and -2. You're going to get the same y values. All right, let's plug in 5. 5. So 5, let's do 1 and -1. Let's see here. So if we get 1 cubed plus the 2 times 1 squared, this is really just going to give us 1 plus 2, which is 3. But now when we plug in the -1, you would see it would change this, but it's not going to change this, the x squared. So we would get -1 cubed, which is -1, and then plus 2 times -1 squared. This is still going to give us plus 2. -1 plus 2 is 1. So this is 1. It's not the same. They're not opposites, so it's neither. All right, you can get these pretty quick. Okay, moving to 6. So 6 looks a little bit different because it's factored out, but that's all right. We can still work with it. Let's plug in 1 and -1. So if we plug in 1, we'll have 4 times 1, which is 4 on the outside, and then 1 squared plus 1. I'm just going to skip to that. 1 squared plus 1 would give us 2. So we're going to get 8. And then -1, when we plug this in, 4 times -1 is -4. And then you see this will stay the same. -1 squared is 1, 1 plus 1 is 2. So you get -8. So you see these are opposites. So this is an odd function. All right. So really, this is a quick way. I think you can kind of see the last 4. You don't have to graph it to figure out if a function is even or odd. The quick check is really just plug in 1 and -1. If these numbers are opposite, like they are here, it's odd. Um, if there's no connection, we say it's neither. And then this one, if it's the same, then you say it's odd.